Okay, folks, we're going to start off today moving into 6-3, multiplying of polynomials. Now, in order to multiply polynomials, we're going to have to start operating with the exponents on the polynomials that we're going to be multiplying with. And when you start operating with the exponents, you have to have some rules to follow. So as we move into 6.3, there is one key rule of exponent that we need to talk about. And this rule of exponent is entitled the product rule of exponents. And here's the proof of this rule. We're going to begin off with this multiplication problem. We're going to multiply these two monomials together, these two powers together. And I want you to notice as we go into the proof of this that the bases of both of these powers are the same. And that is part of the rule. The bases will have to be the same for this rule of exponent to work. So let's prove how we can generate this answer and then get a rule. X to the fourth times x to the third. We're going to begin off by writing out the meaning of x to the fourth. The 4 indicates that the base of x is going to be repeated 4 times. So I'm repeating that x 4 times. X times x times x times x. And then I'm going to bring down that major multiplication sign. And then we're going to write out the meaning of the second monomial factor, x cubed, which would mean x times x times x. If we now multiply this out and write our final answer using an exponent, since there's a total of 4 factors of x here and 3 additional factors of x here, our final answer written as a power should give us x to the 7th. Now here's what we want to be able to do, which I think most people in the room would be aware of this rule. Let's look at the original problem and let's look at the answer that we got. The rule seems to tell us that if we bring down one of the common bases of x, we can take the exponents and add them together, and that too will give us x to the 7th. And that is exactly what the product rule of exponents tells us to do. If a does not equal 0, a to the m multiplied by a to the n will equal, bring over one of your like bases of a and take your 2 exponents and add them together. That's the rule, and that is exactly what we did up here to get an answer of x to the 7th. So we're going to look at 2 quick little examples of this product rule. Then we're going to move into 6.3. 7 to the 6th times 7 to the 3rd. We're multiplying 2 powers that must have the same base. The rule says bring over one of your bases. And then simply take the respective exponents and add them up, and we'll get 7 to the 9th. And that would be our given answer, and we would leave it in that way. Number 2, multiplying negative 3m by a positive 4m squared. We begin by multiplying our coefficients. Negative 3 times positive 4 gives us a negative 12. But now when we're multiplying the powers of m together, this is m to the 1 times m to the 2. The product rule says bring over one of those m's. We'll put it right next to the 12 and add the exponents. The implied exponent here is 1. Added to 2, we'd get an overall answer of negative 12m to the 3rd. So those are just a couple of simplified examples that point out this product rule of exponents. Now we're going to move into 6-3 and we're going to look at the individual skills of multiplying polynomials together. We're going to use capital letters. Capital A, we're going to multiply monomials together. We'll just do one problem here. We're multiplying these three monomials together. And here's what I'm going to suggest that we do as we multiply these monomials together. Because there's three different coefficients up there, and three different powers of A up there, three different powers of B, and three different powers of C, it might be a little bit confusing to the eye if we just try to just automatically multiply everything out and hope that we're adding the exponents correctly. I think a wiser decision to make would be this. We're going to use the commutative property of multiplication, and we're going to kind of change the order of some things up here in these three monomial factors. And we're also going to form some groupings, some brand new groupings. It's called the associative property. And here's what we're going to share. We're going to put one house as we begin this process. And house number one is going to be devoted to the three coefficients of each of these monomial factors that we're multiplying together. House number two is going to be devoted to strictly the powers of A. House number three will be strictly for the powers of B, and house number four will be for the powers of C. House number one, -12 times the coefficient of this middle monomial factor, -1, stick that -1 right in there, and the coefficient of the last grouping, +2. I think it's going to generate a better answer in the long run. House number two is going to be devoted for the powers of A. A to the second times A to the fifth times A to the 1, and I'd show it. The third house is going to be for the powers of B. B cubed times B to the 1 times B to the fourth. And house number four will be for the powers of C. We don't have any powers of C in the first monomial factor, but we've got C to the sixth times C to the first. And now we'll come down and we'll write our answer, and I think it'll be more evident and easier to see what the answer is going to be because we have grouped -12 times -1 times +2. There's an even number of negative factors. The coefficient must be positive. -12 times -1 is 12, and 12 times 2 is 24. Now the product rule that we just proved. We're multiplying powers that have the same base. Bring down that common base of A right next to that coefficient of 24 and add the three exponents. 2 plus 5 plus 1 to the 8th. Right next to that A to the 8th, bring down the common base of B and add the exponents for the powers of B. That too is to the 8th. And then right next to that, bring down the common base of C, add those exponents to the 7th, circle it, it's done. No, I would not advise that you go from the original problem to the answer. I advise that you form groups, put coefficients in the first house, and the powers of A, B, and C in the successive houses. We're going to go to letter B. Letter B. We're going to multiply a poly by a mono, a polynomial by a monomial. And in order to multiply a polynomial by a monomial, we have to distribute. That's the first thing that must be done. We have to distribute. And when we distribute, we use the product rule of exponents when it's necessary. So here we go. We're going to get rid of the parentheses. We're going to distribute. We're going to multiply a polynomial by a monomial. Start with the coefficients. Negative times positive, negative 15. Now the product rule. X to the third times x to the fourth. Add those exponents, x to the seventh. Now the distributor negative 3x to the third to the second term of this poly. Negative 3 times positive 2, negative 6. Now the product rule. X to the third times another x to the third. Add the exponents, x to the sixth. Now the negative 3x to the third to the negative 1x squared. Negative 3 times negative 1, positive 3. Bring down that common base of x, add the exponents. X to the third times x to the second, add those exponents, x to the fifth. Negative times negative, a positive 9. X to the 3 times x to the 1, add the exponents, x to the 4. And then finally, negative times negative, a positive 21. There aren't any powers of x next to that negative 7, so we just take this x to the third that was in our monomial, and just attach it to the 21, x to the third, and there is our answer. We're distributing, and we're using the product rule as we do it. Okay. Number 2, same idea. Positive times positive, positive 28. Now the powers of a to the second times a to the second, add those exponents, a to the fourth. B to the third times b to the second, add those exponents, b to the fifth. Now the distributor to the middle term of this trinomial. Positive times negative, a negative 20. A to the 2 times a to the 1. Add those exponents, a cubed. B to the third times b to the third, b to the sixth. And then positive times positive, a positive 12. A to the second times a to the 1 would be a to the third. And b to the third times b to the first, add those exponents, we'll have b to the fourth. And there's the little product for those. Now we're going to close this session off and see if we can just get this video uploaded. I know it's a shortened form, but we're going to close it off and we'll reunite. Take care.